So very good evening to you people. Today we're talking about once again physics in 24 hours. So physics in 24 hours. So we are there in the journey. In the journey we will go for episode 5. So this is episode 5. So today we are talking about basically a very important concept for beginners or the learners. So who are wanted to become a master in physics, that is vector and scale. So today we're talking about vector and scalar. So we're detailedly talking about vector and scalar. So let's see first one, scalar. So what is meant by scalar? So generally the vector and scalar is applicable for a physical quantity. So I want to learn about physical quantity also first of all. So I want to learn about physical quantity. What is meant by physical quantity? So in day-to-day life, so you have to measure anything. I want to measure anything. I have to measure anything. So that quantity become a physical quantity. So we have to measure any quantity in day-to-day life. In day-to-day life is called as a physical quantity. Is called as a physical quantity. So which means, so in day-to-day life we have to measure. So any quantity, that quantity become a physical quantity. What is the example for this? So let's say length is a physical quantity, mass is a physical quantity, time is a physical quantity, speed is a physical quantity, velocity is a physical quantity. So these are the different examples for a physical quantities. So a physical quantity which is available, then my conclusion, whether it is a vector quantity or scalar quantity, I have to decide based upon certain features. So let's see what are those features. One by one, we have to go ahead. So I hope people are understood what is not physical quantity. So physical quantity is nothing but we have to measure any quantity in day-to-day life. So I want to measure any quantity in day-to-day life. Generally, we go with a concept called as a physical quantity. So let's see the first one, a scalar. What is meant by scalar physical quantity? So a physical quantity which has only magnitude, but not but not direction, but not direction. That physical quantity, that physical quantity, that physical quantity is called as a scalar quantity. A physical quantity. Scalar physical quantity. A scalar physical quantity. So what is a scalar physical quantity, guys? A physical quantity which has only a magnitude but not direction. Only magnitude. That physical quantity is called as a scalar physical quantity. Let's see an example I hope. So example, let's see speed. Speed. So see there's 20 meter per second. So speed is the best example for a scalar quantity. 20 meter per second. What is the meaning of 20 here? So 20 is magnitude. Numeric magnitude. So 20 is the magnitude. So 20 is the magnitude. And meter per second is the unit. So that is the way generally notation is NU. NU is the notation for a physical quantity. So N means number. U means unit. That number is called what? Magnitude. So speed have a magnitude. What is the magnitude value here? 20 kg, 20 meter per second, 20 joules, 20x. This is the best example. Let's see another example. I will code. So mass. Mass also another best example for a scalar quantity. 2 kg. So once again, 2 is what? Magnitude. And this kg is what? Unit. So once again, mass is under the category of a scalar quantity. A scalar quantity. I hope you people are understood. So now we move on to the what is under vector physical quantity. So I want to learn vector physical quantity. So what is meant by vector physical quantity? So vector physical quantity. So now I want to go with vector physical quantity. Vector physical quantity. So what is meant by vector physical quantity? So what is meant by vector physical quantity? A physical quantity, a physical quantity which has both magnitude and direction. That is very very important. Magnitude and direction. So magnitude and direction. So he is called as a vector physical quantity. Vector physical quantity. Vector physical quantity. So this is called as a vector physical quantity. What is the example for this? Let's say one example, velocity. So velocity. So velocity is a vector physical quantity. How can I recognize? Let's see, 20 meter per second in east direction. 20 meter per second in east direction. So this 20 is called as, just now I have told, this is magnitude, and this east is called direction. So it have both magnitude and direction. So that is the way these have a magnitude and direction. So both you have it. So magnitude and direction you have. That is the way velocity become a vector physical quantity. So how to render a vector? So representation of vector. How to represent a vector? So generally, so velocity is a vector that is going to be represented in the form of v bar or v bar. So we have to use any one. So this is the way we have to use it. Otherwise simple, without arrow we put a bar also. So the vector is represented in the form of v bar and v arrow, otherwise v bar. So such a way we need to represent. Is there any other one? Is a vector. Force is the best example. So force is the best example for us. So force a bar or a bar. So this is also one of the example for a vector quantity. So how to render we understood, but how to get these values, how to find out the magnitude, how to find out the direction. So what is meant to be unit vector and what is the compound round resolutions. These are all we have to discuss under today concepts. So let's see guys here. So today we will discuss about all these. First one we go ahead. How to, let us say, let a bar is a vector. Understood that a bar is a vector. So how to represent? Generally vector is represent taking a coordinate system. I am taking a coordinate system. Let us taking different how to represent it. So along positive x-axis, we consider as I cap. I tell you what is motor cap. So along negative x-axis, we consider as minus I cap. Along y-axis, we consider as plus j cap. Along y-axis with minus, we consider as minus j. Along z-axis, we consider as k cap. Along negative z-axis, we consider as minus k cap. So this is the way we have to represent the direction of a vector. Direction of a vector. So how to represent the direction of a vector? So this is the way we have to proceed. Suppose I want to move in. So let us say in the reference point. Let us say who is the reference point. I want to move along the x-axis. So what can I write in this part? I cap. Let's say an example. I move in the direction of x-axis in the 2 units. And j cap 4 units. And k cap 5 units. I have to rotate. So move, I want to move. So how to represent this in the form of vector notation? So a bar is equal to, a bar is equal to, so along the x-axis, how much can I move? 2 units I am moving with along x-axis positive. That is why I put a plus 2 into I cap. So next, j, how many units I moved? So 4 units I moved. That is why I put 4j cap. And in z direction, how much can I move? 5 units I moved in z direction. That is why I put 5k cap. So I will tell you about cap once again. That is the unit vector. I will discuss later part. First, how to render a vector in the form of notation. So this is called as a vector. So let us say take another example. So now I am moved in this direction 2 units, in this direction 4 units. So now what is the vector? So let us say b bar is equal to, so along x-axis with the negative 2i cap, y-axis along positively 4j cap. So such a way we have to represent a vector. So I hope people are understood. So direction, I create the direction. Now the problem is magnitude. How to calculate a magnitude value? So the magnitude of a bar. How to calculate the magnitude of a bar? So magnitude of a bar. So let us say guys here, how to calculate? So what is the modulus formula? Modulus of a bar. This is the formula for modulus of a bar. So root of first I beside value. What is the I beside value guys? 2 square. So we have to square that plus. So what is the j beside value? 4 square. What is the k beside value? 5 square. So now we have to calculate. So 4 plus 16 plus 25. So what do you get? So 45 will get. So this 45 is called what? Magnitude. So I hope people are understood right now. So this 45 is called as a magnitude. And the direction is what? I cap, j cap, k cap are the directions of this vector a bar. I hope people understood. Once again, let us say magnitude of b bar. So how to calculate magnitude of b bar? Modulus of b bar is a magnitude. So now once again, how to calculate? So what is the formula for this? Once again, I beside value how much? Minus 2. So minus 2 whole square, keep in mind. Plus. What is the j beside value? 4. So 4 whole square. So which is equal to root of 4 plus 16 is equal to root 20. So root 20 is the magnitude of which vector? B vector. So like this we have to calculate the magnitude of a respective vector. I hope people are understood. So I discussed about the direction, I discussed about the magnitude. Now the problem with what is cap? I cap tells us. Previously I told how to represent a vector bar. Now we have to get a cap. So what is the meaning of cap? Let's see. So what I meant by unit vector? What to discuss under the unit vector? So we are there in physics in 24 hours. So at the beginners of physics, we want to master in the physics. We have to watch remaining videos from episode 1. So I hope you go through it within 24 hours. We are watching all the videos which is there in that playlist. You become a master in physics. So now we want a unit vector. Unit vector. So unit vector. So how to represent a unit vector? Cap is the symbol for this. Let us say A cap. Let us say A cap. A vector magnitude is unity. What is the meaning of a unit vector? A vector magnitude. A vector magnitude is unity. Unity is called as a unit vector. A unit vector A cap. So what is the formula for A cap? So A cap is equal to A bar by modulus of A bar. So that is the meaning of A cap. So what is the A cap is equal to A bar by modulus of A bar. So that is the meaning of it.